Hi everyone, Assalamualaikum. In this video, we will continue with volume by shell. Okay, we continue with example 4 from previous semester papers. Diagram below shows the region R bounded by the curves y squared equals to 10 minus x and x equals to y minus 2 bracket squared. By using shell method, find the volume of solid generated when R is rotated about the line y equals to -2. Alright? Right, this is the given shaded region. Okay? This is the intersection point, and then this is the curve x equals to bracket y minus 2 squared, and this is the curve y squared equals to 10 minus x. Right? Alright, first we draw the axis of rotation, okay, which is line y equals to -2. Okay, so this is our axis of rotation. Okay, alright, using shell method, okay, if the axis of rotation is a horizontal line, so we need to integrate with respect to y. So all terms in terms of variable y, including lower limit and upper limit, must on the y-axis. Okay. Alright, and then we recall back Washer method. Okay. Under Washer method, if the axis of rotation is horizontal line, we need to integrate with respect to x. Okay, not with respect to y. Okay. But we need to square the outer radius and the inner radius. We have two radius. Okay. But we doesn't have height. Okay. Under shell method, we must multiply the radius and height. Okay. But no square here. Okay. And in front here is 2 pi. Okay. But under Washer method, in front here is single pi. Okay. Alright. After rotation, after the shaded region is revolved about line y equals to -2, so we get this diagram. Okay. This is the original shaded diagram, the original shaded region. Okay. And then from here, okay, since we need to write in terms of variable y, so we write x as a subject. Okay. The original question is given y squared as a subject. So we need to rewrite x as a subject. Okay. So we get 10 minus y squared. Alright. Alright. This is the cross section of this diagram. Okay. We have hollow here. Okay. This is from outside. Okay. Alright. So this is our original shaded region because the axis of rotation is here. Okay. Alright. From volume by shell, we need to find the radius and the height. Okay. Radius equals to the distance between the shaded region to the axis of rotation. Okay. This is our original shaded region. Okay. And then this is axis of rotation. So the distance between the shaded region, the original shaded region, and the axis of rotation is radius. Okay. Right. How to find the radius? Okay. Using shell method. Okay. This is our diagram after rotation. Okay. This is the original shaded region. Okay. And the distance from the shaded region and the axis of rotation is radius. Okay. Alright. Let's say the shaded region we write as y. Okay. Let's say y represent the shaded region, the original shaded region before rotation. Okay. And then -2 represent the axis of rotation because this is the line y equals to -2. Okay. So from here we can see that the original shaded region on the top of the axis of rotation. Okay. So we must subtract from top and then minus bottom. Okay. So we get y minus negative 2. So y plus 2. This is our radius. Alright. We write y represent the original shaded region, and negative 2 represent the axis of rotation. When we compare the shaded region on the top of the axis of rotation. Okay, so top minus bottom, so we get y minus negative 2, which is equals to y plus 2. So this is our radius. Then we can write here. Okay, radius equals to y plus 2. Right? Alright, after that, we find height. Okay, and under shell method, if we integrate with respect to y, means we need to find height using right minus left. Okay, this is our height. Okay, this is our radius, and this is our height. And height is the right function minus the left function. Okay, and from here, the right function equals to 10 minus y squared. And the left function from here equals to y minus 2 bracket squared. So we put here. Okay. Before we subtract, we must write x as a subject. Okay. Right. And then we simplify, we expand and simplify. So we get height equals to 10 minus y squared minus bracket y squared minus 4y plus 4. Alright, from here we have minus sign here. So must put bracket to avoid error. Okay. And then after simplify, so height equals to 6 plus 4y minus 2y. Right? So now we done find the radius and the height. Okay, for shell method. Okay. From the previous slide, we find radius equals to y plus 2 and height equals to 6 plus 4y minus 2y squared. Okay. Alright, we recall back from volume by shell. Okay. If we have axis of rotation is a horizontal line, so we set up the formula volume by shell. We integrate with respect to y. Okay. So we can set up formula volume by shell. Volume by shell equals to 2 pi. We integrate radius times height. Okay. And then we compare with the axis of rotation. Okay, now our axis of rotation is a horizontal line. So under shell method, okay, we need to integrate with respect to y. And when we integrate with respect to y, we need to use lower limit and upper limit on y-axis. Okay, from the original shaded region, okay, in the given question, we have coordinate of intersection point here. Okay, and then we just use the coordinate of y. Okay, because we integrate with respect to y. So we use lower limit and upper limit on y-axis. Okay. Alright. So from the given intersection point here, we use coordinate of y. Okay. So our lower limit y equals to negative 1 and our upper limit y equals to 3. Okay. And after that, we replace radius, okay, equals to y plus 2. We put here. Okay. And then height equals to 6 plus 4y minus 2y squared. We put here. Okay. Alright. After that, from here, we can see that all in terms of variable y, including lower limit and upper limit. Okay. Under shell method, if the axis of rotation is parallel to x-axis, or in other words, is a horizontal line, all terms must in variable y, including lower limit and upper limit must on the y-axis. Okay. Alright, so from here, we can expand and simplify. Okay. So we expand one by one. Okay, after we expand and simplify, so we get this. We still have 2 pi here, and then after we expand and simplify, we get 12 plus 14y minus 2y cubed. Okay. And after that, we need to integrate with respect to y. Okay. So we still have constant 2 here, constant 2 pi here. Okay. After we integrate, and then we integrate 12 with respect to y, so we get 12y plus, we still have constant 14, then we integrate y, so we get y squared over 2. So over 2, we can simplify with 14. That's why we get 7 here. Okay, 7y squared. And then minus, we still have constant 2, and then we integrate y cubed. We get y to the power of 4 over 4 here. And 4 and 2 here, we can simplify, so we get over 2 here. Right? And after that, we replace upper limit first into variable y. And in between must lower limit. Okay, we replace by y by lower limit. Okay. Alright, then we simplify, so we get this negative to the power of even numbers equals to positive. So that's why we get positive 7 here. And negative to the power of even numbers equals to positive. Then we have negative in front here. Okay, so we get negative. Okay, we cannot multiply negative here and negative here, so that we get plus. Okay, it's a wrong concept because we need to solve to the power of 4 first. Okay, then we can multiply by negative in front. Right? Alright, and then we simplify from here, so we get volume by shell equals to 1 to 8 pi units cube. Okay, cube for volume. Okay. Right, from here, we also can use symbol lab to check our final answer. Okay, so from 2 pi and then integrate from negative 1 to 3 y plus 2 bracket 6 minus 4y minus 2y here. After we press enter, so we get this 1 to 8 pi. Alright. So from here, we can see that volume always positive. Okay. If we have volume negative, maybe we make mistake when we find the radius, or maybe when we set up the formula, or maybe we make mistake when we integrate, or when we replace the lower and upper limit. Okay. Alright, so from here, we just leave our answer in pi. Okay. Coming up next, volume by washer versus volume by shell. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.